Hi, my name is Daniel Okouya. I'm a program technologist on the LD4P.
And I'm Josh Greben. I'm a programmer with Library Systems team and on LD4P.
So thank you for coming. Today we're going to present to you the results of proof of concept that we have developed for LD4P, a data pipeline with the objective to help to systematically convert cataloging data into BIBFRAME data such that it can be made available for downstream system, and in particular in this POC, proof of concept, in a triple store. In this case, we are testing, also evaluating Stardog. So we're going to show you a demo here, but before we do that, we wanted to introduce you to the general architecture, because you're going to see a lot of windows. And so for this to make sense, it's important that you understand a little bit the architecture of, that we have been putting in place. So the main component that you have in this data pipeline are Spark, Apache Spark, Kafka, and Apache Stream. So the heart would be Apache Spark, or Spark streaming in this case, where you see here one component, but it's actually our parallelization component. Apache Spark enabled to process content in multiple nodes. In this actual proof of concept, it's actually one master for the cluster and 3 nodes. Each node having 8 cores, which gives a parallelism factor for processing of 24, but actually we reduced to 20. Then you have Kafka, which is kind of the buffer where the data flow in and out and decouple all the applications, producer, consumer, and Spark. And finally, we have Apache Stream, which is the technology that we have used to actually build reactive stream-based microservices. So what is Apache Stream? Basically, is the idea that Spark is very fast at processing data. Kafka is very fast at transporting the data. If you can't produce fast enough or consume fast enough, you mitigate everything you do in the middle. And as you will see, by the way, Spark is going to process the transformation pretty fast. And we will try to struggle, but we will keep up in consuming from what comes from Spark to actually load it in the triple store. And we managed to do that in a way that is the most optimal. By optimal, what I mean is that those reaction streaming components, what they do is that they decouple reading from writing. So we do not wait to read from Symphony. We do not wait that the writing into Kafka is finished before we read into Symphony. We read and we write at the same time, right? And we also parallelize the writing. In this case, for the producer that Josh is going to present later on, we read everything that comes into from Symphony, and at the same time, we write in parallel 100, with a factor of 100, yeah, 100 in parallel, right? That helps us to keep up with the processing of Spark. That's what Apache Stream provides as a technology, is the ease to write those complex concurrent applications. It's supposed to run on one node, not multiple nodes. It's not a parallelization per se, distribution per se, it's just on one node. So now we're going to move to the demo.
Okay, so here you will see, first of all, just to prove that what we're doing is correct, we will see this is the Stardog console, and you can just see that there's basically empty at this point. Okay, and just by the way, also, we've preloaded the ontology in here, so you actually do get the classes and properties. But if we click on one of these things, you'll see there's no data there. Okay, so now I'm going to go over to the Stardog consumer on the box that's running the Stardog consumer. I'm going to go ahead and start running the consumer. And you can see that it's connecting, it started up and it's connecting to Kafka at these Bootstrap servers.
Yes.
Okay.
Spark.
Okay.
The other one. Yes. So as you say, It's waiting for data to come into Kafka. This data is supposed to be processed by Spark. Here you can see a graphical interface to the Spark cluster. You see the 3 nodes where the processing is going to happen. You see the 8 core where the actual tasks are going to be performed. And you see the application here, this one, and you can show the tab with the application. Yeah. So here, you will see the rate at which the data will come. If you go down, the mini batch, you will see them being processed here. So once everything starts, this will be filled up with a number of records that have been processed, and then it will be pushed in Kafka, and then you will see the result in the consumer and then in Stardog. So now we can go all the way to, and this is Kafka here that you see. So basically, the consumer is going to read data from the BIBFRAME topic because that's where the Spark streaming is going to write. And the producer is going to produce data to the MARC21 topic that Josh is going to present now, and then we're going to start the pipeline.
Okay, so now I'm going to switch over to the Symphony server that actually has the catalog data that we're going to produce by doing catalog dumps from the Symphony database, and then run the reactive Kafka dump producer that's going to send the data into the pipeline. So I'm going to go ahead and do that now. We can see we're going to run it against this set of Catalini keys, which is got 36,000 Catalini keys in there. So if I just, you can see those are the C keys. So I'm going to send those to the producer. It's going to catalog dump the record to produce a MARC record and send it off to the pipeline. So I'm going to start this off. I tell it which set of keys to use, and just tell it that we're running this on the Symphony box. So it's starting up there. This goes dumping the records, and it's sending them out in the stream to the producer, as a producer to the pipeline to be consumed.
It's important to understand that this is not, there's no intermediary file. Once the command is run, the result of that command is read and sent at the same time, right? So here we can see on the consumer side, the Stardog consumer that is reading the data from Kafka and writing them into Stardog. That is actually, so how it's done, that's what we were talking about reactive stream. Basically, you have a process that reads the data, and then you have a process that writes. But the process that writes is actually 8 tasks. Each of them is batching up 500 records and pushing them in the store. That's to be able to have the necessary truth of truth. We don't want to be sending 1 record at a time. If we do that, that's going to take forever. So that's why, and what is happening, why it sounds slow, it's not so. It's what is happening is that we are saying, hey, read me 500 records within 20 seconds or else send it. So if in 20 seconds I don't have 500, that's what it's saying. And that means somehow that we are killing the Symphony box because it's not keeping up with how fast we need to read, actually. Yeah, because the dev box, basically. Now we can show the Spark streaming to see how, I think Spark streaming already finished at that point. Yeah, the other one, refresh. Can you, yeah. Can you go a little bit up? So basically, no, you go down. So there's no more active batch. So basically, the processing is done. No, that's not okay. Can you refresh again? Or it's too fast, actually, so we can see. That's it. It's too fast. So we don't even have the time to see the actual active batch because as soon as you process it, it's already in completed batch. If you see the time, you can see that the time evolves. You can refresh. The time will change.
Oh, there's an active one.
We saw.
Yeah, you saw it for a second.
Fast. It's really fast. The Spark streaming is very fast, and it's sending those things down there. So you barely have the time to see when it's actually processing. And if you look at that, it's 284 records being transformed in 0.5 seconds. So that's why you don't even have the time to see it going through. You can refresh again, maybe we can be lucky this time. Yeah. Okay. So I think everybody understands that the thing is processing pretty fast. And then you can show Stardog on the other side. Yeah, Stardog, that the data is in Stardog.
Okay, so we're back to Stardog. I'm just going to go ahead and refresh this page where we were before, and you can see now there's data there.
Can you go back to the, yeah, and you saw the instance or the work? click on it. There was, yeah, so go ahead. So that's the instance data that you can see here. Maybe you can show work, it's easier to read. At the bottom, yeah. So let's get into one of them.
Since this collection is all Italian,
we don't know.
Right, Castellini stuff is mostly Italian works, right? So.
Yeah, there is a bit less information. I was not familiar to it, but I was told that this is how bibliographic data looks like.
What data looks like.
So, and if you look at the instance here. Yeah, so this is the browser, the built-in browser of Stardog, and it's guessing the actual property to show, right? Like the LDFS label and so on is guessing that and showing that to us. So where we are here, that process actually, the 36, we can say in advance that the 36 Castellini record takes about 8 minutes to be processed.
36,000.
36,000. So yeah, now it's like getting those 500 records and writing them. So we didn't put the, but that's okay. Yeah, that's about it. So you can see that the data is still coming in MARC21 because the Symphony box is struggling. Despite the fact that we are really writing 100 records in parallel. So we read and then we split the task 100 and pushing that. Kafka is very fast, so you can take it. But it would be foolish for instance to write like 100 in parallel in Stardog, because that's a typical database and you need connection pooling. That's why we reduce it to 8. How long have you been talking already?
Are you doing fine? So this is all running on the Amazon Web Service?
Yes, this is running. Oh, in the meantime,
with the exception of the Symphony producer, which is our locally hosted system.
So maybe talk about that for a second.
Can I switch back to me?
Yep. So you would just go back to
share screen.
Yep.
So in the meantime, I will use the opportunity to explain a little bit better what we saw here. So we have the dump producer and the update producer. So what you are seeing right now is the dump producer going to the dump streaming. So what is it? Basically, to have a pipeline, you need 2 steps. The first step is the replication that can be done in parallel because the order in which you replicate the data is not important. We call it the dump. I say replication because it's akin to database replication / with a transformation in the middle, right? So you do that first phase. And then the second phase is to have a pipeline that actually take every change that is happening in Symphony and replicate them. So first you replicate the data as it is. And the requirements for both processes are different. When you are doing a dump, so an initial replication, you can parallelize completely. The order doesn't matter. When you are propagating the change, you need to pay attention. It's sequential in nature. So that's why we need 2 different processes, 2 different pipelines, basically. So the idea would be the one that we're running right now, we run it once, and then we put the second pipeline, and then this one runs continuously and keep transforming. As far as this proof of concept, we have finished the first one, the initial one, the one that you're seeing, and we have scaffolded basically the continuous one. So whenever that's like another 3 days work, and it will be done. Basically, to have the continuous process. Thanks to the work you did around reading the his log and being able to see what Symphony is doing and then propagating that. Yeah, so we can switch back. I hope it's finished. Is it done? Yep. Here it's done.
Okay, here you can see the Symphony has stopped sending records. That process is finished. And
it's dwindling down.
Still picking up. You can see the number of records, batches is kind of petering out.
So I think those are the last ones, basically. We should be done in less than a minute now.
Interesting how it dribbles at the end. Yeah, so it's waiting for that 20-second interval to expire because it would fill up that block with 500, but otherwise it's waiting for a timeout.
Exactly. And
that's all tunable, but those are pretty good parameters.
Yes. So here it's finished as well. Spark streaming is done. It's not batching anything anymore. If you go down, you can show that now it's taking 0, 0, 0, 0, and more down you have the processing that happened before. All right, so it is done. So if whoever is watching the demo has taken the time to put this, I don't know, chronometer, I don't know how to say that in English. Stopwatch. The stopwatch. I hope you can verify that it took about 8 minutes to process 36 records. This is good benchmark if we compare to what we did before. I don't know if you have the numbers, how long it would take.
No, I don't know. I mean, for the catalog dump to go to SearchWorks,
it's 36,000.
We do it overnight and.
Yeah, it's hours. Yeah.
Hours, yeah.
Okay.
36,000, a dump of 36,000 from Symphony probably takes 8 minutes just by itself. Without
just to get the file to start.
Just to get the file to start.
Yeah.
So we have a magnitude improvement. Again, this is available, like it's consumed in Stardog, but it can be consumed and sent to SearchWorks Center. So when we make the data available, it's with eventual consistency guarantee. So eventually all those downstream systems are going to be consistent. And if you are writing to Solar, I suspect that it's going to be faster because this is a triple store. The consistency model is strong. In Solar, you are distributed, and you have also already eventual consistency inside of the distribution. So it's a little bit faster actually to write in Solar. So it should finish before Stardog, basically. Less than 8 minutes, I suspect. Voila.